In this video, we talk about the standard normal, random variable, and also how to calculate probabilities in general for normal random variables. So the standard normal random variable is a pretty special type of normal. It's just a normal random variable that has mu equals 0, meaning it's centered at 0, and then standard deviation 1. So what does this mean? If we think about our 68, 95, 99.7% rule, this means that if we look at mu plus 1 sigma, that would be 0 plus 1. And mu minus 1 sigma is 0 minus 1, so we get negative 1. So between, let's call this one z, the probability that z is between negative 1 and 1 is 0.68. And similarly, if we look out two standard deviations, then we have negative 2 to 2, and the probability that z is between negative 2 and 2 is about 0.95. And then similarly, the probability that z is between negative 3 and 3 is about 0.997. Okay, so that is our standard normal random variable. It just means it's centered at 0 and has standard deviation and variance equal to 1. Now, we talked about how to find probabilities for a normal random variable in very specific cases, like if we had one standard deviation out or two standard deviations out or three. But of course, we may sometimes want to know, for example, what's the probability that z is greater than 1.5. And we would not be able to figure this out using the 68, 95, 99.7% rule. So what we can do instead is use just a probability calculator. So if you have like a graphing calculator, you can use that. If you're familiar with R, you can use that. I'm going to show you how to use just a really simple online tool. You don't need to do any downloads or anything. It's just a website. So let's find the probability that z is greater than 1.5. So we go to stattrack.com/online calculator, blah, blah. Give it the mean and standard deviation. So the mean is 0 for standard normal, and the standard deviation is 1 for standard normal. And I want to know what's the probability that z is greater than 1.5. So let's try typing in 1.5 and see what happens. We get 0.933. So let's think about that number there, 0.933. Does it seem like this area here could be 0.933? No. So what that website is giving us is the probability that z is less than 1.5. So that's this purple area here. This is equal to 0.933. But not all is lost. In fact, now all we have to do is do 1 minus that number because we know that the total area under this curve is 1. So the probability that z is greater than 1.5 equals 1 minus the probability that z is less than 1.5. So in other words, 1 minus 0.933 would be the probability that z is greater than 1.5. Okay, so this pink area here is 0.067. Okay, let's do one more example. In the example we just did, we had a standard normal distribution. Let's go back to having just a different normal distribution. And let's have mean 1, and then standard deviation equal to 2. Okay, so mu equals 1, that means it's centered at 1. If we drew out our plus or minus 2 standard deviations, we'd have 3 here and -1 here. And we know that there would be 68% between -1 and 3. Now, let's find the probability that x is greater than 4. We know that our website gives us the probability x is less than 4. So let's find that first. And then we can do 1 minus the probability that x is less than 4, and that will give us the probability that x is greater than 4. So what's the probability that x is less than 4? Let's give it our mean of 1, our standard deviation of 2, and we tell it that we want to calculate it for 4. We hit calculate, and we get 0.933. So let's go fill this in, 0.933. Therefore, 1 minus 0.933 is 0.067. So this pink shaded area is 0.067. Okay, but wait a minute. Earlier, we saw this exact same number, 0.067. So what could be going on here? The thing is that all normal distributions are related to each other. So this point right here on the standard normal distribution is directly related to this point right here on the normal distribution with mean 1 and standard deviation 2. In fact, we can say the following. So let's say if x is normal with mean mu, and standard deviation sigma, then x minus mu over sigma is standard normal. So let's check this out. Earlier, we were interested in the value 4. Let's see how 4 on the normal with mean 1, standard deviation 2, is related to the value 1.5 on a standard normal. So let's take this and plug in some values. So x minus mu over sigma. The value that we're looking at right here is 4. So let's plug in x, 4. And then the distribution had mu equals 1, standard deviation equals 2. So let's plug in mu equals 1, sigma equals 2. And so we get 3 over 2, or 1.5. And so we can see that the value 4 right here is related to this value 1.5 on the standard normal distribution. So back before they had like nice probability calculators for normal distributions, what they had to do was translate everything to a standard normal distribution. And then they had tables and pages of probabilities for just the standard normal distribution, because we knew that if we wanted to find the probability that x is greater than 1.5, that would be the same thing as finding the probability that z is or rather, the probability that z is greater than 1.5 is the same thing as the probability that x is greater than 4. So if we were working on the example with the grades from last video. That was centered at 75 and had standard deviation 5. Okay, so let's say that anyone who's getting 63 or lower has to do some makeup assignments. We want to know what proportion of students earned a 63 or lower. So we're looking for the probability that X is less than 63. Usually we use the letter Z for a standard normal. So this is the same thing as the probability that Z is less than 63 minus mu, which here is 75, divided by sigma, which is 5. So this is a probability that Z is less than, so 63 minus 75 is -8, and then we have over 5. Now we can go calculate what's the probability that a standard normal is less than -8/5. And we get 0.055. So about 5.5% of students will need to do some extra work because they earned a 63 or lower on their exam. Okay, so lots of times you'll hear this called the Z-score, and that just means it's your original cutoff here minus mu divided by sigma. That's what's called your Z-score. All right. In future videos, you'll get some more practice using these.